For this video, we'll be discussing how to work with the Java class library. The objectives of this lesson is the student should be able to explain object-oriented programming and some of its concepts, differentiate between classes and objects, differentiate between instance variables, methods, and class or static variables and methods. Explain what methods are and how to call and pass parameters to methods. Identify the scope of a variable. Then cast primitive data types and objects, and compare objects and determine the class of an object. So, introduction to OOP or Object-Oriented Programming. So, Object-Oriented Programming revolves around the concept of objects as the basic elements of your programs. These objects are characterized by their properties and behaviors. So, you will learn what are properties and behaviors in our next slides. So, objects. So, any object, let's say for example, in the real world, a car is an object, a person is an object. So, these are objects. So, here are examples. So, car is an object, a lion is an object. And the car actually have what we call properties. So, like for example, what type of transmission this car is. Is it automatic transmission or is it manual transmission? Manufacturer, so is it Toyota, Honda, Mitsubishi? So, anything. Color, is it black, white, red, gray? So, these are properties. And it also has what we call behavior. So, these are something to do with action. Like say for example, the car can be turning to the left or turning to the right, or it can brake, or it can accelerate. The same is true with the lion. Lion is also an object, so it has properties like the weight of the lion, the color of the lion, whether the lion is hungry or not, whether the lion is tamed or wild. And it also has some behavior or action like roaring, it can sleep, it can hunt. So objects in the physical world can easily be modeled as software objects using the properties as data and the behaviors as methods. So the properties here will be the data itself or the attributes, and the behaviors will be what we call methods. So we'll learn more of this as we go on. Encapsulation. Encapsulation is the method of hiding certain elements of the implementation of a certain class. By placing a boundary around the properties and methods of our objects, we can prevent our programs from having side effects wherein programs have their variables changed in unexpected ways. So, some methods and variables can be inside a class, and then we can also change the accessibility of these classes. So they're inside, that's why we call it encapsulation. Classes and objects. So a class can be thought as a template or a prototype or a blueprint of an object. It is a fundamental structure in object-oriented programming. So we always start with a class. That's why it's a fundamental structure. And there are two types of class members. These are the fields, or these are the properties or attributes which specify the data types defined by the class. And then the methods which specify the operations. So we have the fields or the properties or attributes and the methods. So again, these are the class members. So these are the things that we can see especially inside the class. Classes and objects. Object is composed of a set of data or properties which are variables describing the essential characteristics of the object, and consists of a set of methods or behavior that describes how an object behaves. An object is actually an instance of a class. So what I mean is, for example, car is a class. And then, for example, you have a friend with a Toyota car. So that Toyota car is an object which is actually an instance of the class, which is actually the car. So an instance of the class. So that particular car is the object. And in general, these are cars, and car is the class. So we can explain that again further using this slide. So we have classes and objects. To differentiate between classes and objects, let us discuss an example. So we have a car class. A car class, so these are the variables or maybe the properties. We have plate number, color, manufacturer, and current speed. So these are the properties of car class. And then these are the instance method. It can accelerate, it can turn, it can brake. And then here we have a particular car. And this particular car is the object. Is an object. So this is the class, that's the classification or a template, and this is the real object. So car A here, so plate number, this is the plate number of this particular car. Its color is blue, Mitsubishi, and the current speed is 50 kilometers per hour. And then object B, so it's another car. So this is the plate number, it's red, it's Toyota, and with the current speed of 100 kilometers per hour. So the objects are the specific object. So these are instances of the car class. Classes provide the benefit of reusability. Software programmers can use a class over and over again to create many objects. So if we have a class, then we can create several objects based from that class or using that class. So you will learn more of this as we go on. Class variables. So classes consist of instance variables, instance methods, and class variables, or sometimes we call the static member variables. So the class variables are variables that belong to the whole class, not only to the object. So this means that they have the same value for all objects in the same class. So it is not a variable for the particular object, it's for the whole class. That's why it's called class variables, or these are static member variables. And we will have you will learn more of this as we go on. So to show you this example, again we have our class car, and these are the instances. So we have object A and object B, and we have class variable. So the class variable is not particular to the object but for the whole class. It says here count equals 2, and these are now our methods. So you learn we will learn more of this as we go on. So again, take note of class variables or static variables. Class instantiation. So to create an object or an instance of a class, we use the new operator. So new, this is the operator new. For example, if you want to create an instance of the class string, so remember, string is a class, not a primitive data type. That's why it starts with an uppercase letter S. So we write the following code: string str2 equals new, so that's the new operator. String hello world. Although the string is a special class, that's why we can write this one like this. But of course, the more formal way of declaring an instance of a class is something like this. So this is the class, this is the object. Okay, this is the object. So if you still remember our examples a while ago, this is the name of the class and this is the particular object. So str2 here is a reference to the string object. So that's a string object. Class instantiation, so the new operator. The new operator allocates a memory for that object and returns a reference of that memory location to you. So we can refer to that particular memory address. When you create an object, you actually invoke the class constructor. So here, this one is actually a method. And this method is what we call the constructor. So we actually invoke that method. So we'll be seeing more examples of this. So it's a method where you place all the initializations. It has the same name as the class. That's why if you notice here, the name of the class is string. The name of the method, the constructor method, is also string. So they should have the same name. This is not the name of the class. This is the method or the constructor, while this is the name of the class. So methods. A method is a separate piece of code that can be called by a main program or any other method to perform some specific function. So some sort of there's an action. That's why it performs a specific function. So the following are characteristics of method. It can return one or no value. It may accept as many parameters it needs or no parameter at all. Parameters are also called arguments. After the method has finished execution, it goes back to the method that called it. Why use methods? The heart of effective problem solving is in problem decomposition. So you have to divide and conquer. You have to create small methods or small programs or codes to solve a big problem, programming problem. So we can do this in Java by creating methods to solve a specific part of the problem. So taking a problem and breaking it into small, manageable pieces is critical to writing large programs. So if you have a large program, then it will be better to write small and manageable pieces of code rather than to write all your codes for that particular program without breaking it into small, manageable pieces. So calling instance variables. So to illustrate how to call methods, let us use a string class as an example. You can use the Java API documentation to see all the available methods in the string class. And later on we will create our own methods, but for now let us use what is available. So to call an instance method, we write the following. So the name of the object, dot, and then the name of the method, followed by parameters. So remember, name of the object, dot, name of the method, parameters. So here are some examples of methods that we have in the string class. So you have the char at. So the char at returns the character specific index, so an index range. So that's the function, but it doesn't matter here for the meantime. So equal, ignore case is used to compare a string to another string. So are they equal? For example, so it returns true or false. That's why it says here Boolean, while this one returns the character at this position. Okay. So example, string str1 equals hello. So this is the object. This is the class name. So again, we can use equal to new string and then hello. And then here, this is the name of the object, that then the name of the method. So again, name of object, that name of method. If you're going back here, name of object, that name of method, and then we have here the parameters. So that's how we call an instance variable. So name of object, that, so these are methods. And then here also, str2 equals hello, Boolean result equals str1, that equals ignore case str2. So we're comparing, so this is again the object, we're comparing it to this object str2. Are they equal while ignoring the case? So actually the results here should be true because they are actually equal, except that this one is using uppercase, but here it says here that it will be ignoring the case, so they will be equal. Okay, so anyway, what you should remember here is to call a method or a variable, we have the name of the object followed by a dot and then followed by the method. I know you've been doing this previously, like for example, integer that parse int, system that out, then that print line. So there are two methods within the one. So pass by value, parameter passing, pass by value. When a pass by value occurs, the method makes a copy of the value of the variable passed to the method. So pass by value, we're just giving the value. The method cannot accidentally modify the original argument even if it modifies the parameters during the calculation. So why can we modify? Because what we pass is just a copy of the value, not really the variable itself, but the copy of the value. All primitive data types when passed to a method are passed by value. So example of pass by value here. So let's take a look at this code. We have here a class and we have here a function or a method here, test, and we have the variable j, which is actually a primitive data type. Okay, so here initially I is 10. If you print I, it will print 10. If you test I, so 10, the value 10, not really the variable I, but the value 10 will be passed to j. And here you notice that we changed the value of j, but although we changed the value of j, since we only pass the value 10, not really the variable I, that's why we call it pass by value. Even though we change the value of j, there's no effect to the variable I. So if you print I here, I will still print 10. That is passing by value. Then we have the pass by reference. When a pass by reference occurs, the reference to an object is passed to the calling method. This means that the method makes a copy of the reference of the variable passed to the method. However, unlike in pass by value, the method can modify the actual object. So that's the difference. The method can modify the actual object that the reference is pointing to, because what we pass here is the reference or the address of the object. Since although different references are used in the methods, the location of the data they are pointing is the same. So they are pointing to the same memory. So here's an example of pass by reference. So we have here an array, ages, so 10, 11, 12. And then we have here a loop. This will print the contents of the array, so it will print 10, 11, and 12. Then we have test ages. So ages here is no longer a primitive data type because it is actually an array of. So what will this pass is the address of the array. So the address of the array will be passed here, and inside this you notice that we change the value of the elements by adding 50. So once we go back here and print ages, this will no longer print 10, 11, 12, but it will print 60, 61, and 62 because we added, we added 50. We added 52, so it should be 50, 51, 52. So what will be printed here is 50, 51, 52. Okay. So this is passing by reference. So the ages here is an array which is pointing to this memory address. When we pass this to a method, what we pass is the address also. So every time we change the value in the address, it will also change the original value here. So calling static methods. So static methods can be invoked without instantiating a class. Means without invoking the new keyword. Static methods belong to the class as a whole and not as a certain instance of an object of a class. Static methods are distinguished from instance methods in a class. Definition by the keyword static. So to call a static method, just type, so this time around, not the object name but the class name. That and then the static method name and then the parameters. So example here. So these are static methods. System is an example of a static method. Integer is an example of a static method. So integer to hex string, that's another example of a static method. You notice they are in uppercase. These are not names of objects but names of classes. That's why again, let's go back. Class name. That and then the static method name. Then let's proceed now to the scope of a variable. The scope determines where in the program the variable is accessible. determines the lifetime of a variable or how long the variable can exist in memory. The scope is determined by where the variable declaration is placed in the program. To simplify things, just think of a scope as anything between the curly braces. So if you declare a variable inside this curly brace, then the variable can be referenced inside. So nakikita yung variable inside. The outer curly braces are called the outer blocks, and the inner curly braces are called the inner blocks. So variable scope is inside the block where it is declared, starting from the point where it is declared, and in the inner block. So it includes the inner blocks, but not the outer blocks. So take note of that. So example here, we have integer I and j, and then we have here a block starting from this up to this. So that means that I and j can be referenced here. We know it can be here. But here, we cannot use the variable j before we declare the variable j. That's why you notice here, I will be this range. Everything is inside this range, but I will start from this range up to this range. In j, after declaring, you can start with j. K, M, N are here, so N is only here, starting from this, but not before these two. Okay. So the code we have here represents 5 scopes indicated by the lines and the letters representing the scope. Given the variables I, j, k, m, and n, and the 5 scopes a, b, c, d, and e, we have the following scopes for each variable. So the scope of variable I is a, the scope of variable j is b, the scope of variable k is c. So a. So starting from this, I can be declared reference. So here, I mean to say here. So it's starting from this because this is we already use I here. So j from this up to this, k, and then d, and then e. So d and n is e. Example 2. So ages. So ages will start from this. The variable I will start from this up to this loop. Outside this loop, the variable I is no longer as if it no longer exists. So ages can still be inside here. Again, the variable I starts from this. Outside this, the variable I is no longer existing. So once we pass our reference here, again, this is another variable I. You notice here, this I here is different from this and different from this variable. So ARR here can be referenced anywhere inside here. So in this main method, the scopes of the variables are ages is scope A, I is in B is scope B, I in C is scope C, ARR is scope D, and I in E is scope E. So I in E, so the variable I, etc. Scope of a variable. When declaring variables, only one variable with a given identifier or name can be declared in a scope. That means that if you have the following declaration, integer test equals 10, integer test equals 20, your compiler will generate an error since you should have unique names for the variables in one block. Okay, so they are in a single block, so they should have unique names. However, you can have two variables with the same name if they are not declared in the same block. For example, so we have the integer test, and then in another block, another integer test. So that means that these two variables with the same name are two different variables. Coding guidelines avoid having variables with the same name declared inside one method to avoid confusion. So actually we will end the first part of this lesson here, and the next part will be on the second part of this lesson. So thank you very much for viewing this video.